In this last video of the course, I wanted to go over two clinical papers looking actually at the effects of augmented reality. So all the technical papers will say that it's a good thing. Surgeons seem to say that it's a good idea, but when you actually come to measure it, does having an image overlay actually help? It's been found in other areas such as aviation with fighter pilots. Their helmets have got head-up displays that actually augmented displays can actually be quite detrimental. So it was quite interesting reading these. In this first one here then is a setup where, well, the title is Surgeons Blinded by Enhanced Navigation, the Effect of Augmented Reality on Attention, which kind of gives away the conclusion obviously. But the general gist is, we can see here, this was done on a cadaver. They had a bunch of different volunteers and they had to find this target point here. I did search through the paper and I don't really know what the target is. So I guess on standard endoscopy, they've just identified it on the CT scan and they know where they're going. But the point about this study is that they've introduced into the cadaver essentially a foreign body here, which is a screw. It's not terribly clear to me. And then they've also done something to the optic nerve. So for whatever reason, I think they've put it through this hole and put the optic nerve there. So it's not meant to be there. In the augmented reality display then, they've got the target that they're aiming for. So the question really is, well, they explained to the participants that they had to go and find this target, and they were aware that they were being timed, and then they had a questionnaire which basically asked them afterwards, did you see these two features here? So the short summary is then the fact that, scrolling down slightly, firstly, if you look at the the location, so who could find the target point and put their pointer on it most accurately, using standard endoscopy is the pink dots, and you'll see that they are more dispersed. So the actual accuracy of placement or targeting something is worse in standard endoscopy. With augmented reality, these blue dots here are more tightly clustered, and you can just about see the target point there as being really kind of at the center of these blue dots. So the augmented reality was more accurate. But if we look at these questions that were asked afterwards, here we have in this column group A and in this column group B. So group A, so did you see this complication, the one with the optic nerve? So 7 out of 17 found it in group A and 0 found it in group B, the augmented reality group, so 0 out of 15. Foreign body, did you find that screw basically? Again, 7 out of 17 found it in group A, and again 0 noticed it in augmented reality. When they were told specifically was it a screw, did you find it? Only one person, so in this case 7 found it in the standard group and only 1 in the augmented reality group. And essentially either finding noted. Okay, this is a summary statistic, just whether you found either one of, any one of them. So it turns out that the augmented reality is more accurate, and we can see here the time to completion is lower for augmented reality. So typically an augmented reality paper sort of tells or promises that you'll be more accurate and you will be quicker. So it seems to suggest, if you only quote those two statistics, that it's a good thing. However, as it can be seen here, it completely distracts you from anything else, and those other things may be more important. And they've seen the same thing with, again, with fighter pilots, where if they have augmented displays, they concentrate on the augmented display and they might miss a much more pressing and urgent need that needs addressing first. So again, I'll summarize it there, or leave it there, because the other paper I want to look at then, which only came out last year, so relatively new, and this is an interesting study in itself. Perfect registration leads to imperfect performance. The reason this is interesting, because on the Smart Liver project we've spent a lot of time trying to overlay our graphics on top of the video, mainly because that's what the surgeons tell us they want. So in this study, if I again scroll down to the picture, basically what they're doing, and I apologise because it's only black and white, but what they have here is, here's the operator, and they are working on what's called the Lap Mentor. It's a simulation suite. So it's made by Symbionics, which has now been bought by 3D Systems, and it's a proper tool for training people. It's a simulator for training people how to do laparoscopic cholecystectomy, so that's gallbladder removal. And they've got, if you go into the literature, there's a nicely designed syllabus, so there are a specific number of tasks they have to perform, there's specific types of operations, and you work your way through this syllabus, and the syllabus has been designed and tested, and they know that, for example, when you've done a certain number of these, that they know how much that you've reduced your training time for doing it for real. So it is actually part of the training curriculum now for surgeons doing this. This was done at Imperial, but they've got the same kind of thing at the Royal Free. Anyway, it's a training suite, so it's got a certain number of patients' CT scans in, and then they use fancy computer graphics to just make it look like real video. So what the group here have done to assess this is they've come up with 3 groups. One of them is just no guidance, so it's purely the simulation software. So what you see on the screen is like the video, and you just perform the operation. The simulation is quite realistic, it's got haptic feedback and everything. So you perform the simulation and it measures everything from like how quickly you move your tools, the total time it takes, what kind of complications you caused. So the first condition is no guidance. The second condition is just having this on this left hand screen, a registered CT scan here on a separate screen, but with no video. You do the registration using this iPad in the middle. So the left hand screen is their second system, as it were, and it's just guidance. They can look at the CT scan, but it's not augmented reality. And then the third one is that they actually take, bearing in mind that this is generated from, it's all virtual anyway, they actually give, and again you possibly can't see it if this is grayscale, but the system is rendering simulated video, so they also then get it to render a perfectly registered chunk of the model as if you were doing augmented reality on top of the video. They then basically assess a bunch of different metrics. I mean, for the purpose of this short explanation, again, we'll leave you to read the paper. Being a sort of clinically focused paper, there's quite a detailed description of all the statistics. But the analysis basically shows that in most of the tasks where they're actually measuring some of the actual performance of what you were doing, the image guidance, so no augmented reality, came out quicker and more reliable, And even on the questions which were asked of the surgeon, basically which one did they prefer, they also came back and preferred, broadly speaking, the image guidance one and not the AR, which again is contrary to some of the surgeons that we've been talking to at the Royal Free. So overall then, so the image guidance does show some benefit over no guidance, and say somewhat counterintuitively it is actually better than the augmented reality. So to summarize, these two papers together do really kind of show that whilst everyone thinks augmented reality is a good idea, it's still quite a difficult usability question as to work out, when do you have these displays on? How can you make sure that putting a display doesn't cause, putting an overlay on top of a video doesn't cause other problems? I guess they've tackled this more in other industries. This paper does, or no, the other paper, Dixon's paper, does note that most of the research out there is really just focusing on registration, because if you haven't got something registered, then it's not much use. But then this 2019 paper is actually showing that the surgeons prefer something unregistered, just roughly in the right viewpoint. And actually they do perform better with the image guidance but not the augmented reality. So I think that's a useful point to finish the course. There's still lots of research to be done. It's not just about registration, tracking and calibration. The actual big issues of getting this to the operating room really are around usability, surgeon's experience, surgical training, visualization, all the human computer aspects, and these are really only just starting to come out now, so lots to be done in the future. And that's that.